In 1985, a scientist from Hungary stuffed $1,200 into her daughter's teddy bear and fled. She had no job waiting, no funding, no future. 40 years later, her research saved 20 million lives. But the institution that rejected her collected $2 billion from her work. Katalin Karikó grew up in a small Hungarian town with no running water. Her father was a butcher. She earned a PhD in biochemistry by the time she was 27. But in 1985, her lab lost its funding. Communist Hungary was cutting science budgets. She found a position in America at Temple University in Philadelphia. The government would only let her take $100 out of the country. So she sold the family car on the black market and sold the money into her 2-year-old daughter's teddy bear. She still has that bear. Karikó believed in something no one else did. She believed that messenger RNA, a molecule your body used to carry instructions between cells, could be turned into medicine. Instead of injecting drugs, you could inject instructions and let the body make its own cure. In the 1980s, almost no one thought this was possible. They call it a dead end. She applied for grant after grant from the National Institutes of Health. Every single one was rejected. Reviewers said her work was too risky, too slow, too unlikely to succeed. Without funding, she couldn't hire students or get her own lab. She bounced from lab to lab at the University of Pennsylvania, working in borrowed space. And then, in 1995, everything fell apart at once. Her husband was stuck in Hungary. A visa problem kept him there for 6 months. She was diagnosed with cancer, and the University of Pennsylvania gave her an ultimatum: give up mRNA or accept a demotion and a pay cut. She chose mRNA. Her salary dropped below that of her own lab technician. She was demoted 4 times, but she never stopped. One day in 1997, she was standing at a photocopier. An immunologist named Drew Weissman was waiting to use it. They started talking. She told him she could make any mRNA. He was looking for an HIV vaccine. They began working together. In 2005, they discovered something extraordinary: a tiny chemical modification that made synthetic mRNA invisible to the immune system. They submitted their findings to Nature, rejected. Quote, an incremental contribution, Science rejected too. It was eventually published in a smaller journal. The paper has since been cited over 1,900 times. The University of Pennsylvania never gave Karikó tenure. They told her she was not faculty quality. In 2013, she announced she was leaving for a small German biotech company called BioNTech. Her colleagues laughed. They said BioNTech doesn't even have a website. She left anyway. 7 years later, a pandemic hit, and the fastest vaccine in history, Pfizer-BioNTech and Moderna, were both built on Karikó's discovery, the modified mRNA technology she has spent 40 years developing. The vaccines were 95% effective. They saved an estimated 20 million lives in their first year alone. They generated over $120 billion in revenue. When Karikó heard the clinical trial results, she said, I was grabbing the air. I got so excited I was afraid I might die. She celebrated by eating a whole bag of chocolate-covered peanuts. In 2023, Katalin Karikó won the Nobel Prize. 28 years after being demoted for the same research, the University of Pennsylvania, the institution that called her not faculty quality, has collected over $2 billion in royalties from her patents. She still has the teddy bear. If you want more stories of forgotten heroes, I'll tell one every week.